All right, guys, welcome to this channel. In today's video, we'll be looking at conservation and dissipation of energy, and this is for AQA textbook, so it's for those who are doing AQA. And also, if you are writing, if your exam body is not AQA, maybe it's Edexcel or OCR, you can also benefit from it. And also, we'll have a video for especially for Edexcel and for OCR, even on this channel. All right, but then today we will be focusing on AQA, which is conservation and dissipation of energy. I believe this is the first topic in the textbook, and then it talks about changes in energy stores. So now, the first thing I would like you to understand is that what is energy? When you say energy, what do you mean? What is the definition of energy? Now, in a very simple term, energy is the ability to do work, which means energy is that thing that you will have before you can do work. Now, there are forms of energy. That is, energy exists in different things, and these are things called energy store. That is, energy can be captured in different ways, in different things in nature, and those are the stores of energy. You have chemical energy store, that is chemical energy store. Chemical energy store is the energy that are stored in chemicals like petrol, food. Food is also has chemical energy stored, like wood. You know, you can burn wood, and the process of burning wood is a chemical reaction. And also, another way to look at chemical energy store is that chemical energy store is the form of energy that can be released by a chemical reaction. So that's just it. So if you have a form of energy that the energy can be released by engaging in chemical reaction, then that's the chemical energy stored. And so when you look at petrol, it makes a vehicle move because it has chemical energy in it. And the ways by which you release the energy is when you burn it, when it reacts with oxygen, when there is combustion. That is when the energy can be released. Also in food, the food you eat, the energy in the food, when it is being oxidized by oxygen, that is when the energy can be released, and that's food for you. That's chemical energy. For firewood, when you burn it, when you combust it, that is when you engage it in chemical reaction, it produces fire. It releases heat and light. That's what is in fire, heat and light, and that's energy. So these are chemical energy stores, and we also have many different energy stores. So I just want you to understand this concept, and then let's go back to the textbook. It says cars, buses, planes, and ships all use fuels as chemical energy stores. You can see that fuels is the same thing I named petrol here. And then electric trains use energy transfer from fuel in power stations. Electricity transfers energy from the power station to the train. That is, in electric trains, they use the electrical energy is generated in the power station by converting chemical energy to the electrical energy. That is the energy in fuel. Then they convert it to electrical energy. Now, electrical energy is being transferred to the train, and that's what makes the train move. You see, the electrical energy is the form of energy that can be transferred or that can be released as electricity, as electric charges, as electric current. You understand? So that's for electrical energy. But then for chemical energy, they can be released through chemical reaction, and that's basically it. It says energy can be stored in different ways, and it's transferred by heating, waves, and electric current, or when a force moves an object. Now here are some examples. Chemical energy stored, it includes fuels, food, or the chemicals found in batteries. Exactly. So these are energy, forms of energy that can be released through chemical reaction. It's as simple as that. Now, kinetic energy stored describe the energy an object has because it is moving. Now let me demonstrate kinetic energy for you. When an object is fixed at a point, when an object is fixed at a point, it has something we call potential energy. Potential energy. That's the form of energy it has. Potential energy. Now, when an object is moving, that object has kinetic energy. Kinetic energy. So kinetic energy is the form of energy that an object has when it is moving. But immediately the object stops moving, then its kinetic energy stored is finished. Then you now have potential energy stored. Do you get it now? So it's very simple. When an object is moving, it has kinetic energy. Then when it stands, when it's standing still, when it's not engaging in any movement, then it has potential energy. And that's it there. Then we have gravitational potential energy stores are used to describe the energy stored in an object because of its position, so that's an object above the ground. Exactly. Now, an object cannot have gravitational potential energy stored until it is above the ground. Now, I believe you understand law of gravity, right? Gravity is when something goes up, is the force that pushes that thing, bam, that pushes it down. So when you have something go up, gravity will push it down. So this is gravity here. It pushes things down. But then when an object is on the floor, let's say this is the floor. When an object is here, gravity cannot push it more downward because, it's on the floor already. Where will it go? So this object is not yet under gravitational potential energy store. It's not under gravitational potential energy. So the gravitational potential energy store of this object is 0. Why? Because it's on the ground. It's on the level ground. It's on the floor already. It cannot go more downward. Now, if you raise this object to this level, then you have granted it a level of gravitational potential energy stored, and gravity can now push it downward. Let's say you throw the object up, then you have given it, by throwing up, you are giving it gravitational potential energy. So as it's going up, its gravitational potential energy store is increasing until it gets to that point where it's now stopped. Then it begins to come down again. So as it's going up, its gravitational potential energy is increasing. That is, you are giving it, you are suspending it to a position that will make the force of gravity have effect on it. That's just the meaning. So that's for gravitational potential energy stored. So gravitational potential energy stored is the energy that an object possesses when it is above the ground. When it is above the ground, so that gravity can work on it. And then elastic potential energy stored describe the energy stored in a springy object when you stretch or squat it. Just like gravitational potential energy stored, gravitational potential energy stored, is the energy that an object has when it is above the ground. That is when the force of gravity can act on it. But then for elastic potential energy is the energy that a springing or an elastic substance has when it is being stretched. Let's say you have a rubber band, something that can stretch, an elastic rubber that has this shape, and this is the shape of the rubber when you do not stretch it. So as the rubber is like this, it is not yet under any elastic potential energy stored because you have not subjected it to a position or situation where elastic energy will have effect on it. So it can only has elastic potential energy stored when you stretch it to become like this. So when you stretch it to become like this, maybe you stretch it with your 2 hands. Now, it now has elastic potential energy, because as you are stretching it, you are increasing its elastic potential energy, such that if you should leave it, the elasticity will bring it back. It will return it back to its original shape. Do you understand? So this is the extended, or let's say extended mode of the object, and this is the resting mode of the object when you have not stretched it. Resting mode. This is the resting mode, and let's say, all right, let's call this stressed mode. Stressed mode. So an object is not under elastic potential energy until it is stressed. So when the object is in stressed mode, then it is under elastic potential energy. But when it is not in the stressed mode, when it is in the resting mode, it is not under elastic potential energy. So is the energy that an object has when it is stressed or when it is expanded. Do you understand now? All right, so thermal energy stored describe the energy of a substance, the energy a substance has because of its temperature. So thermal energy, another name for thermal is heat. So thermal, when you say thermal, you are talking about heat. Is the same thing as heat. So thermal energy stored is the energy stored when heat is being supplied to an object. When heat is being supplied to an object, that is when the temperature of the object will increase, and that is when the object is said to have thermal energy. All right, then it says energy can be transferred from one store to another. Now, on a torch, the torch battery push a current through the bulb. This makes the torch bulb emit light and also get hot. Now, it also says when an electric kettle is used to boil water, the current in the kettle's heating element transfer energy to the thermal energy store of the water and the kettle. Now, let me demonstrate this for you. Energy can be transferred from one store to another, and that is when you said energy has been used to do work. Energy cannot be said to have performed the work until it is being transferred from one store to another store. So the process of transferring energy from one store to another store is the process of using the energy to do work. Now, let's say we have a torch. This is a torch, a flashlight, and then it has, of course, it will have this side that will emit the bulb. The bulb is somewhere around here, and then it is like this. All right, and then you have the switch. The switch will be around somewhere around here, and then it will have some batteries inside of it. All right, so let's say this is a torch, is a light, a flashlight. The batteries will be connected, of course. All right, so let's say this is a flashlight that emits light, but then the energy change or the transfer of energy that happens here from one store to another is what brings about light being given out, because the whole energy starts as the chemical energy inside the battery. Chemical energy is inside the battery because it is chemical reaction that brings about the production of electric charges inside the battery. Chemical reaction. So the energy inside the battery is chemical energy, but then the battery as a mode of the kind of chemical reaction that occurs in the battery is such that it transfers the chemicals, the chemical energy in the battery to electrical charges. So you can now say chemical energy from the battery to electrical charges. So chemical energy from the battery to electrical charges. So as you put on the switch, there will be chemical reactions inside the battery, and then the chemical reactions inside the battery will convert the chemical energy inside the battery to electrical charges. The electrical charges will then run through the wires. There will be wire inside of it. We run through the wires, and then we go to the bulb. Now, when the electrical charges gets to the bulb is a substance that has the ability to transform electrical charges to light and heat, and that is when you say the flashlight is producing light. So the chemical charges, the electrical charges will go to the light bulb, to the bulb here. Now when they get to the bulb, let's say there's a wire that connects the bulb to the battery. Now when it gets to the bulb will transform the electrical charges to light, which is what you see, and then heat. I believe you know that when light is being produced, there is the production of heat too, because of the internal energy of the bulb and all. But then you need to know that when light is produced, the heat is also produced. It is being produced as well. And this is the energy transference or energy change that happens in a flashlight. That is, number one, chemical energy in the battery is being transferred to electrical energy that's for electrical charges in the wire, and then the wire takes the electrical charges to the bulb, and then the bulb changes the electrical charge. It transfers them to light waves and heat, which is thermal energy, and that's for this. And then we also have the example of a kettle, an electric kettle. So let's say this is an electric kettle. I'm not a good drawer now. All right, so let's say this is an electric kettle here, and then of course there will be a cover to it, and then there will be something you can handle. Now let's say this is an electric kettle, and this is the point from which you connect it to the electricity. So let's say this is the electricity, and it's being connected to electricity. So this is where you connect the kettle to the electricity. Now immediately you switch on the socket, the wall socket, the electric socket here, then electric charges will run through the wire to the kettle. Now the kettle has something inside of it called the element. The element has the ability to convert or to transfer electrical charges into heat, into thermal energy. So from electrical energy to thermal energy, and then it will transfer the thermal energy as heat to the water that is inside the kettle, or whatever you put inside the kettle. Let's just assume it is water inside the kettle now. So it will now transfer the thermal energy to the water inside the kettle, and before you know it, the water will begin to boil, and you begin to see steam come out of this place. And the energy transfer that happens here is that electrical charges or electrical energy from the light source, it comes into the kettle, and the element in the kettle transfers the electrical energy store to thermal energy store in the kettle, and then it transfers the thermal energy to the water or whatever is in the kettle, and that's how the food in the kettle is being cooked. So it's just a transference of energy from one store to another, and this is when work is set to be done, like I said earlier. All right, so let's look at other stuff. It says when an object is thrown in the air, the object slows down as it goes up. Here, energy is transferred from the object kinetic energy store to its gravitational potential energy store. Exactly, just like what I explained earlier, that an object does not have gravitational potential energy store until it is being thrown upward, or it is being lifted above the ground. So as you lift it above the ground, you know that when something is moving, the kind of energy it has is kinetic energy. So as the object is moving upward, the kinetic energy store is being transferred into its gravitational potential energy store as it's moving. Then it will get to a point, the whole kinetic energy stored will be transferred into the gravitational potential energy stored completely. And when it gets to that point, it will now begin to come down. It will begin to come down. So the gravitational potential energy store will also begin to be transferred to the kinetic energy stored of the substance. But in this case, it's not going up again, it's just coming down. But even when it is coming down, the energy store that it has is kinetic energy stored. So it will come down until the whole kinetic energy stored is being converted to its potential energy stored. So it will now come to the floor and then remain there, or probably bounce and still, maintain the position. All right. Now for the torch, the chemical energy stored in the battery is being converted to the electric current in the wire. That's the electrical charges, and then the wire will send it to the bulb. The bulb is what transfers the electrical energy to light waves and thermal energy in the surrounding. Now, energy transfer. It says when an object starts to fall freely, it speeds up as it falls. The force of gravity acting on the object causes the energy to be transferred from its gravitational potential energy stored to its kinetic energy. That's what I explained earlier. When an object is falling, then its gravitational potential energy, when you throw an object up, it's going up, so it has gravitational potential energy being increased from the kinetic energy. So energy is being transferred from the kinetic energy stored to the gravitational potential energy stored as it's going up. But then it gets to a point when the whole kinetic energy stored is being transferred to the gravitational potential energy stored. At that point, the object cannot further go up. Then it will get to a point that it will begin to come down. It will begin to come down. The moment it starts coming down, then the gravitational potential energy stored starts to be transferred into the kinetic energy stored. But in this case, it's not to go up, but to come down. So it's just like an action, then you have an opposite action. So an action is what takes it up from kinetic energy to gravitational potential as it's going up. But then as it gets to a point where it cannot further go up, it starts coming down. And the moment it starts coming down, then there is transfer of energy from the gravitational potential energy stored back to the kinetic energy stored until the whole kinetic energy now is being transferred to the potential energy stored. And then it gets to the ground and it becomes still there. All right. So you have gravitational potential energy stored, and then kinetic energy to the kinetic energy stored. So from the kinetic energy stored, that's when an object is falling now from the gravitational to the kinetic, and then from the kinetic, then it transfers energy to the surroundings, which is the increase in the thermal energy stored of the surrounding. Of course, when an object lands on the ground, it produces a kind of heat, because the landing of an object on the ground brings about friction, and you know that friction always produces heat. So when it lands on the ground, it produces heat. That's what generates the heat. And also the sound waves, of course, it will make sound, and sound wave is also a form of energy too. All right, so that's the transfer of energy between one point and another, between one energy store and another. Now let's try to answer these questions together. It says, describe the changes to energy stores that take place when a ball falls in the air. So when a ball falls in the air, the changes in the energy store that take place is that the gravitational potential energy store of the ball is being transferred to the kinetic energy store of the ball. Then as the ball gets to the ground, the kinetic energy store of the ball is being transferred to sound, which is, of course, when the ball gets to the ground, it produces sound. So it's being transferred to sound wave and thermal energy of the surroundings. Thermal energy of the surroundings. So it produces a level of heat because there is friction between the ball and the Earth's surface. All right, then it says, describe the changes to energy store that takes place when an electric heater is switched on. Now, the changes in the energy store is that when an electric heater is switched on, then electrical energy store from the wall socket, from the main electricity, is being transferred to the element of the electric kettle. The electric heater, and the element in the electric heater transfers that electrical energy to thermal energy. So in a statement, you can just say, when an electric heater is switched on, then electrical energy stored is being transferred to thermal energy, which is heat. Now, number 2 here, it says, list 2 different objects you could use to light up a room if you have a power cut. For each object, describe the energy transfer and changes to energy store that occur when it lights up the room. Now, number 1 thing you can use is you can use a candle. You can use a candle, that is, when you I believe you know something called matches. So you can use matches or probably a lighter or something to produce fire. So when you produce fire, you now put it on the candle, then it begins to burn. The candle burn is a local way of producing fire. So now you can use candle to light up a room, of course. You can use candle to light up a room, and when you do that, then the energy transfer is that the chemical energy in the candle, because the burning of a candle is a chemical reaction. Don't forget, the burning of a candle is the chemical reaction. So the chemical energy, anything that has to do with burning is chemical reaction. So just know, anything that has to do with burning is chemical reaction. So the chemical reaction, the chemical energy stored in the candle is being transferred to light, which is the light wave. Of course, the fire will produce light, and heat which is thermal energy. So you can say the chemical energy stored in the candle is being transferred to the thermal. The chemical energy stored in the candle is being transferred to the thermal energy, and also to light waves to lighten up the room. And also another way by which you can light up a room is when you use a flashlight, a torch, like I explained earlier. So then in the torch you have battery, and then you have a switch. So when you put on the switch, the chemical energy stored in the battery of the torch is being transferred to electrical charges to the wire. Then the wire takes the electrical charges to the bulb, and the bulb transfers the electrical charges to light and heat, which will eventually light up the room. All right. Now the B says, which of the two objects in A is easier to obtain energy from? So which one is it easier to obtain energy from? I believe the one that is easier to obtain energy from is the candle when you produce fire. Or let's say you light up a wood and you put fire on it. Probably the candle is just the best example for that. So the candle can be used, it can be easily used to get energy. And also it says which one is easier to use. Of course, the flashlight is easier to use because it produces less heat. And the heat that a naked fire will produce is, you can't compare with the heat that a flashlight will produce. Although a flashlight also produces heat, but it's not as much heat as the heat that a candle will produce, that a naked fire will produce. So the one that is easier to use is of course the flashlight. All right. Question 3 says, describe the changes in energy stores of an electric train as it moves up a hill at constant speed. Now, an electric train, for an electric train, there is electrical energy from the power station that is being transferred to the train. The train now transfer the electrical energy to kinetic energy. So it's the electrical energy that makes the train to move. So the train is what transfer the electrical energy being given to it to kinetic energy, which makes it move. And that's the answer to that. It says, as the train approaches a station and brakes to a halt. Now, this is another thing. As the train approaches a station and brakes to a halt, the energy change involved is that the kinetic energy that the train is using to move is being transferred to, number one, when you apply the brake, it will bring about friction. Friction is what makes the wheel of the train to come to a stop. So as you apply the brake, kinetic energy of the train is being transferred to heat. Number one, because there is friction, so there is production of heat. And number two, is being transferred to sound, because it will produce sound. You will hear some sound, whoo, or something. So the kinetic energy of the train that the train is using to move, approaching the station now, the kinetic energy is being transferred to both heat and to sound, even as it comes to a halt. Then it says, number 4, it says, describe the changes in energy stores that take place when food is heated in a microwave oven. Now, in a microwave oven, of course, there is you plug the microwave oven to the electricity, so there is production of electrical charges. So you look at the origin of the energy before you really determine what will be the answer to the question. You look at the origin of the energy. Now, when you it says describe the energy that takes place when food is heated in a microwave oven. When food is heated in a microwave oven, the electrical energy stored from the electricity is being transferred to the oven. So, but then the oven now transferred the electrical energy stored to electromagnetic wave. A microwave oven does not produce heat per se. It's electromagnetic wave that eats up the food substance through I think infrared radiation or something. So it's electromagnetic wave that heat up the food. It's not really heat. So it's electromagnetic wave. So the electrical energy stored is being transferred into electromagnetic wave, which eventually is being transferred to heat that heat up the food. So from electrical energy stored to electromagnetic wave, then the electromagnetic wave generates heat that heat up the food. All right, so that's it about this video. Please, if you find value in this video, give it a thumbs up, that is, like this video, and also please click on the subscribe button, subscribe to this channel. On this channel we'll be rolling out we'll be explaining the textbooks topic by topic, and we'll be answering the questions thereof, and we'll also be answering AQA, GCSE past papers. So we'll be solving them on this channel live. So it's something that will be of a great benefit to you. So you need to subscribe to this channel. If you find value in this video, and also share this video to those that you know would love it, your mates in school, your colleagues. Share it to them, tell them about this channel, let them come here and learn even about this topic, and also about the subsequent topic that we'll be posting. Thank you very much. See you in my next video.